Hello everyone, let's take a look at LeetCode 42, trapping in water. And it's a hard problem, and it also can be solved by different solutions. Let's take a look at it today. This interview question is also very popular. For example, Facebook uses it a lot. Okay, so the problem is, given a non-negative integers representing an elevation map, where the width of each bar is 1. So we need to compute how much water it can trap after raining. For example, the height is 0, 1, blah, blah, blah. And the graph will look like this. And the output is 6. So one naive solution for this problem is like for each index, like for each bar, we can compute how many water it can rain. For example, for this bar, the height is 0. We can iterate the left side and find the highest bar in the left is 2. And in the right side, the highest is 3. So for this one, if we have water, the water will like flow like through the bar that has the height 2, right? Since this is it's lower than the right highest bar. So the leftmost height is 2. The height of this bar is 0, so it can trap 2 unit water here. So one naive solution is like for each bar, like for that particular bar, we can find the highest bar in the left, and we can find the highest bar in the right. Then we can get the minimum one between the two, and we can compute how many water it can trap in that bar. Okay, it can pass the test cases, but the speed is very slow. We can see that it's almost 400 milliseconds. Since the time complexity of this solution is O(n) square. Yeah, based on that, we can optimize it. So each time we don't need to for loop the left, for loop the right to find the highest bar in left and highest bar in right. We can create like 2 DP arrays. We can pre-process our input, and for each index, we can get the highest bar in the left and highest bar in the right. So it only takes O(n) to build the DP array, and it also takes O(n) space. Then we can improve the whole time complexity to O(n). Since for each height, it only takes O(1) to query the DP array. Okay, but this solution still use O(n) space. Like how can we improve the space like maybe to O(1)? Okay, we can use 2 pointer. So this is basically all the variable we need. We have a pointer point to 0, and we have another pointer j point to the last, and we have max left. The maximum left keeps the highest bar like before I. The maximum right keeps the highest bar after j, and we initialize result to 0. Finally, we just return this result. Okay, let's see how can we get the correct answer. Let's just go through the whole process for this example. At first, height I is smaller than height j, so we move height I. Then at this point, height I is also like smaller or equal than height j. In this case, we also move I. Okay, then we update the maximum left to 1. Okay, in this case, maximum the height I is also smaller than height j. So we need to process height I, and the left max left is 1. This has height 0, so we can trap 1 unit water here. So result is update to 1. Okay, now height j is smaller, so we move j and update maximum right. Now we move I, then we update maximum right. Now we also move I and add result. Yeah, and we do the same one since height I is smaller, so we move I and add 2 units here. Okay, and at this point, we can add 1 unit here. Okay, now height j is smaller, so we move j and we update maximum right to 2. At this point, height j is also smaller, so we move j and update result to 6. At this point, height j is smaller, so we move j. Okay, now the while loop will break, and the final answer is 6. Okay, so most important question here, like why this algorithm is correct? Okay, this is our algorithm. If height I is smaller or equal than height j, we process I, otherwise we process j. Okay, so why this algorithm is correct? Let's take a look at this example. Is it possible that I is here, j is here? Then we know the leftmost is this one. The highest in the left is this one. So we add the highest in the left minus height I, which is the blue bar here. From this graph, looks like the some of the blue bar, like some water here, it will flow like through here, like in the right side, right? Seems it's not correct. But let's think about why I can be here, why I can be moved from the leftmost index from here. Since we always move the smaller one, we always move the lower one, right? It means there must be some bar in like on the right side of J that is pretty taller, like taller than this one. Otherwise, we cannot increment this I. Since we move this I, so there must be some bar on the right side of J that is taller, right? So the blue bar, the blue water will not flow on like the right side. Okay, so that's it. See you next time.